Example 5, we're looking at conduction, right? Conduction through a styrofoam cooler. So, in here, we are given a styrofoam box. Let's just write down all of our given information. We're told that the total area within inside the walls has already been nicely calculated for you, and it's just simply told that it's 0.8 meters squared. We're told the thickness of the wall, that's L, is 2.0 centimeters. And I'm looking at this and I'm thinking, centimeters, probably got to change it to meters, right? Got to have it in normal SI units, so 0.02 meters. The box is filled with soft drinks and ice and whatnot. So inside, we're going to assume the temperature inside the colder area is 0 degrees Celsius. And then on the outside of it is a nice hot day, and it's 30 degrees Celsius. We're also told the heat conductivity, right? Thermal conductivity, not C. I've just been thinking about specific heat for some reason. Conductivity, K, right? Thermal conductivity is given as 0.010 joules per second times meter times degrees Celsius, or it could be Kelvin. So you're asked to find the rate at which heat flows. So rate, that's Q, over time. That's what we're looking for. It's a power, essentially. Okay, so do I have some space down here? I get the answer here. Let's go to solving this, right? So if you recall, if you look back in our notes here, and we're looking at solving thermal conductivity, we're essentially using this equation on the AP formula sheet. So the heat flow per time, right? The energy per second is given by the thermal conductivity multiplied by the area multiplied by the change in temperature all over L. So let's plug that in here. Okay. So Q over delta T equals K A delta T all over L. All right, so then we just plug into this. Thermal conductivity is 0.010 joules seconds times meter times degrees Celsius. Okay, multiplied by the cross-sectional area, 0.8 meters squared, multiplied by the thickness of the walls. We need to change that from centimeters, so that's 0.02 in meters. And then divided by, oops, I'm making a mistake here. That thickness goes on the bottom, right? That's 0.02 meters here. And then delta T is the change in temperature. So how much does this change in temperature? That's 30 minus 0. Remember, it's hot minus cold. So it's 30 degrees Celsius. Okay, if you look through the units here, you can hopefully see that. I always check my units. These degrees Celsius cancel out. There's a meter squared with a meter down here, and then another meter over here. That all cancels out. And so you're going to end up with units of joules per second. So that all makes sense. So just be careful with the units. Remember that you need to have everything cancel out nicely. So Q over delta T is 12 joules per second, or I guess you could write it as 12 watts. Where W is a watt, which is equivalent to a joules per second. Okay, that's it for this example.